Today we're really going to get to take a look at these types of problems. This is, I believe, page 27 or 29 in your packet. We didn't get to take a look at these, and so I wanted to make a quick video kind of give you guys the concept of how to do these problems. I didn't want to do exactly these ones because I want to make sure that you guys have some practice to do. So I made up some other ones that are very similar to these questions. So what I'd like to do is just take a quick look at 3 questions, kind of see how it's set up so that you guys can hopefully get an idea of how to do these problems. Before we start looking at the problems, let's look up here at these 4 equations. These are going to be the 4 equations that we're focusing on here. We have 2 different types. We have the OR equations. Those are the ones where we're going to be adding 2 things. And then we have the AND equations, the intersection equations, where we're going to be multiplying those 2 things. Now, each of them has 2 different situations. The multiplying has independent events and dependent, where the addition or the union problems have mutually exclusive or overlapping. So let's take a look at how we can use these equations to answer these questions. First question says, it is known that events Q and R have the following probabilities. Probability of Q is 0.3, probability of R is 0.5, probability of Q union R is 0.6. What is the probability of Q and R? So when I look at this, my mind wants to go directly to this equation. Probability of Q and R should equal the probability of Q times the probability of R. The problem with this, using this equation up here, is that this assumes that these events are independent. We don't know if they are or not, so we can't assume that. So what we have to do is, instead of using this equation, we look more at what information do we have in the problem. So let's erase that and take a quick look. So we have a single probability Q, a single probability R, and then we have the union of those 2 probabilities, Q union R. So I'm going to look back up at my equations here. Let's erase all this extra stuff. And what we want to do is figure out what information or what equation has these 3 parts of information. So if we look, and also the part that we want to solve for. So we have this individual probability. This is what we want to solve for, Q and R, in this case A and B. And then they also give us this piece of information, the probability of A union B. So what we're going to do is we're going to use this equation because this is the one that has all the pieces that we need to solve this problem. It has the 3 given pieces of information and the piece we want to solve for. So now all we need to do is put this information into the equation. So we have the probability of Q union R, it's going to be over here, is 0.6. All I'm doing is I'm substituting into this equation here. So 0.6 is the union. Probability of A, well, for this problem, it's going to be the probability of Q, it's 0.3. Probability of R represents the probability of B in the equation, so 0.5. And then probability of A and B is what we're actually solving for, the probability of Q and R. So we're going to subtract probability of Q and R. Now from there, we just need to solve for that. So what we can do is, instead of writing that to make the problem a little easier, we can call that x. So we solve from here. We get 0.6 is equal to 0.8 by adding the 0.5 and the 0.3 minus x. Subtract your 8, divide by your -1, you get x is equal to 0.2. The final answer. And that's it. So that means the probability of Q and R is equal to 0.2. That's it. Final answer right there. Let's take a look at the next one. So this next one says events H and Q are independent events. What is the probability of H and Q if probability of H is 0.25, probability of Q is 0.6? So in this problem, it specifies that these events are independent. So what that tells me is I should go up to those formulas, and again, those are on your sheet here. Go up to these formulas and find the one that says independent. That's going to be that formula. So that's the formula I'm going to use. Let's write it down here. The probability of A intersect B is the probability of A times the probability of B. Again, I got this equation because it specifies the events are independent events, so I have to use the independent events equation. From here, we're going to substitute my values. What is the probability of H and Q? Write that in. Probability of A, that's going to represent the probability of H for this problem, so that's 0.25. And the probability of B is going to represent the probability of Q, which is 0.6. Now from here, we're just going to multiply those two probabilities out. And I believe you should get 30, so 0.15. From there, if we wanted to, convert that to the percentage of 15%. And that's it for that one. This one, the key thing we needed to know was that these were independent events. Once we knew that, we knew the equation to use and try to put our values in to solve. Okay, one last type of problem, and this video will be done. This problem is talking about the probability of Kara being grounded and that she's passing all her classes 15%. So let's kind of abbreviate there. It says the probability of Kara being grounded and passing all her classes. So grounded and passing is 15%. Okay. Then it says the probability of Kara being grounded given that she passes. That's different than this and up here. So the probability that she's grounded given that she's passing. Notice the difference. This is the and, this is the given. So that probability is 20, or 0.2 they say, which is just 20%. To keep our units consistent here, so make that percent as well. What they want to know is what's the probability of her passing her classes. So with this, I have a given probability, I have an and probability. So I need to do, we're going to scroll back up here to our formula. We're going to look for an equation that has a given probability and an and probability. Not that one, not that one, not that one. This one has an and a given. That's the equation I'm using. So scroll back down, take a look at how we can fill in those values. So that equation we just identified was the probability of A and B is equal to the probability of A times the probability of B given that A already occurred. So let's see how we can take these values up here and substitute them into our equation. So first off, the probability of G and P. So what that's going to be is that's going to be this value, this and probability. So that's going to be our 15 there. Probability of A, that's going to be this value, our unknown, so the probability of P. And we're going to multiply that by our given probability. In this case, our given probability is G given P. So that's going to be 20. From here, we need to solve this equation for the probability of P. So to do that, we have something times the probability of P, so we're going to divide by it. Divide one side, have to divide the other. And what we get from there is that the probability of P is equal to 15 over 20, or 3 over 4. We should know that that would be 0.75 as a decimal, or 75% as a final answer. And that's really all there is to these problems. The key thing is being able to identify what equation to use based off the information you're given in the problem. Once you identify that equation, one of these four up here, all you have to do is substitute in your values and solve for the missing piece. Hopefully this video helps you out on this homework assignment. And if you do have any questions, feel free to message me on Remind. Have a good day off tomorrow, and we'll see you guys on Wednesday.